Hi guys, and welcome to Distilling's training area. My name is Annalise, and today we're going to be talking about our proper turbo yeast. Or actually what we're going to be doing, we're going to perform some experiments on our turbo yeast. So firstly, what is turbo yeast? So turbo yeast is basically a mixture of yeast, nutrients, and buffering agents mixed in specific quantities in order to get a fermentation that can be done within 5 to 7 days. And this is only used for sugar wash fermentations. And if you've ever made sugar wash fermentations using baker's yeast, brewer's yeast, and some of your wine yeast, for instance, you will notice that it takes quite a while. It's not done in a week. It sometimes takes up till 10 days till 14 days, and in some cases even longer. So the nice thing about turbo yeast is that it's done really quickly, and another advantage is that it can tolerate higher alcohol concentrations, which means we can add more sugar, and more sugar means a better alcohol yield. So that's basically the advantages of using turbo yeast. Also, what's really nice is you don't have to do pH monitoring, you don't have to do regular nutrient additions. You literally just take the packet, cut it open, pour it into your prepared sugar wash, and it's done in about a week, even less than a week. So that's the nice thing about turbo yeast. But today we're going to do some experimentations using different concentrations of sugar and seeing how the turbo yeast reacts to it. So we're going to have, you can see in front of me, we've got 3 buckets. Each contains different amounts of sugar. One contains less than the recommended sugar concentration, or the sugar dosage rates. The one contains exactly as the manufacturer instructs us to do it. And then the last one contains more than what is recommended. So a lot of our clients has been adding more than the packet actually instructs. So they've been adding 8 kgs of sugar instead of 6.4 kgs of sugar. So today we're going to actually test that, whether or not the turbo yeast can actually handle more sugar than what is said. So we have done a experimental video before where I actually go through the steps on how to properly conduct an experiment. So today I'm just going to go through that quickly. I'm not going to go through each step in a lot of detail. So first things first, I already said my scenario. So my scenario was I've got 3 different sugar dosage rates. I wanted to test whether or not and how my yeast can actually tolerate it and how it will actually react to it. So my first aim, I'm actually just going to be doing 2 experiments. The first aim, the aim of this experiment is to test whether or not my proper turbo yeast can complete fermentation within a period of 72 hours, so that's 3 days, with an expected alcohol concentration of 14% ABV, with a fermentation temperature at between 30 and 32 degrees Celsius. So remember, in your aim, there's a lot of information given. So the first set of information given is what type of yeast I'm going to be using. So in this case, I'm going to be using proper turbo yeast. Then, my second thing in my aim, it has to complete fermentation within a period of 72 hours. So I'm giving it a time period within when it has to complete. Then I'm also specifying how much alcohol, of the potential alcohol it should produce, so I can translate that into the amount of sugar I need to add by a simple calculation. And then the last thing is the temperature at which it ferments. So 30 to 32 degrees Celsius, that means I'm going to have to apply additional heating. So I'm going to be using fish tank heaters. Now my second experiment, the aim of this experiment is to see whether or not proper turbo yeast can ferment 8 kgs of sugar in a 20-liter wash, similar to a fermentation with a recommended sugar concentration of 6.4 kilograms. So I basically want to see is, if I add 8 kgs of sugar, is it going to give me the same results, the same success, the same fermentation time than what I would have done if I'm using 6.4 kgs of sugar? So if it ferments dry, it ferments within the same more or less period, then from now on I'm going to add more sugar instead of just using 6.4 kg. Now, next thing after you've specified your aims is I need to research the topic, I need to read up. So I need to make sure that my yeast can tolerate 30 to 32 degrees Celsius, which it can. I need to make sure that I'm using the right dosage rate. So 6.4, I need to know that is the recommended rate. So I have to go read up on it to actually be able to compare it. And then the last thing, I need to work out how much is 14% alcohol ABV, how much sugar should I add to get an alcohol concentration of 14%. And that can be done through a simple calculation. Now the calculation is STA, which means sugar to add, equals, your alcohol potential, so what you want to achieve, times volume, which is going to be 20 liters, times 17. That 17 is just a constant. It basically just means for each, if you want alcohol, each percentage alcohol you want, you need to add 17 grams of sugar. So that's basically what that means. So let's quickly work that out. I only have one calculation I need to do because I've already specified 8 kgs and 6.4 kgs. So the only one that I don't know how much sugar to add is my 14% ABV. So I just want to go use my calculator. So alcohol potential is going to be 14 times volume, which is 20, times 17. It's going to be 4.76 kgs of sugar. So let me just write that in. So it's going to give you an amount of 4,760, but I'm just going to convert that to kgs. Okay, so now my research is done. Then I need to design my experiment. So I need to firstly decide or specify what is my independent variable. My independent variable is going to be my amount of sugar added. So this is this thing I actually control, how much sugar I'm going to add. Then my dependent variable is dependent on my independent variable. So this is going to be influenced by this. So I cannot control the fermentation rate or success. That is what I'm actually trying to find out doing this experiment. So my dependent variable is going to be my fermentation rate, so how long does it take, and is it going to ferment dry? It doesn't help that I add 8 kgs of sugar and it gets stuck halfway through. Then I need to make sure I've got everything else as constants. My constants is going to be literally everything else. My fermentation temperature, my dosage rate, my volume that I'm working with, the type of yeast I'm using. So everything else should be exactly the same, except my sugar concentration. Then what you also need to do is make a list of consumables needed for this experiment. Trust me, you want to prepare beforehand. You don't want to start and then halfway through you figure out you've got something missing, and then your whole experiment is a little bit screwed up. So I've got actually a list here. No, this is not the stuff. There we go. So I just wanted to get my list. So firstly, I'm going to need some of my measuring equipment. So I'm going to need my SG hydrometer, which I'm going to be using to measure my sugar every day. I'm going to need my measuring cylinder. I'm also going to need my pH meter. This is actually not really necessary for a sugar wash because we don't, or for a turbo yeast fermentation, because the amount of buffering agent added is literally enough to make sure when your fermentation is done, you don't actually have to add any more potassium carbonate or so. It contains the exact required amount to make sure that your fermentation doesn't go too acidic, but it is going to be interesting using this, seeing how does the pH change. You're going to need your beakers, one for water and one for your fermentation, to actually measure out your pH. Also your paper towel to dry your probe of your pH meter. We're also going to be using a thermometer to make sure that our fermentation stay within the specified fermentation temperature range, so that 30 till 32 degrees Celsius, and this also applies for my second experiment. So all of them is going to have the same fermentation temperature. Then I am going to need my a method of mixing my fermentations. So I've just got a drill here and then a paint mixer. This works really, really well. It also gives you a lot of aeration, so oxygen is very important during fermentation. I know there's a lot of people that's really scared about oxygen, but those people has been a bit misinformed. Oxygen actually helps your yeast cell walls to build nice, a lot of sterols, and sterols actually helps your yeast to be able to tolerate more environmental stresses, which means it can actually go a little bit further into fermentation if it has that sterols embedded in its cell membrane. Then I'm going to be needing 3 packets of turbo yeast. All of them is 100 grams. It's the exact same yeast. And then I'm also going to be needing my fermentation locks, 3 of them, because I've got 3 buckets. And what's really going to help is obviously my scissors. I'm going to need a pen because I am going to monitor the fermentation. So I'm going to be writing down all of the sugar concentration, the pH, and the temperatures twice a day. So make sure you've got something like that. And then also very important, sodium metabisulfite. So I have sterilized these buckets before use. And when I am done measuring my sugar concentration, I'm going to sterilize my SGI hydrometers and my beakers so that during the day it is clean and there's nothing that can grow on that. We are in an environment where we're working and packaging a lot of yeast, so I don't want any contamination in my sugar washers with my proper turbo yeast. So this is basically the consumables I'm needing. So first things first, how I'm going to start it. I'm going to firstly need to measure out my different sugar concentrations. So firstly, I sterilize my buckets. Then I'm going to measure out my sugar required, and I filled each of these buckets with the right amount. So this one is my lowest. This is going to be my 4.7 kgs of sugar. This is my 6.4, and then thirdly, this is going to be my 8 kgs of sugar. So I have done that just using a normal scale. Then what I'm going to need to do is I'm going to have to dissolve this sugar with a little bit of hot water until it's almost fully dissolved, and then I'm just going to top it up with 20 liters. I'm then going to be using my thermometer to check whether or not my temperature is below 35 degrees. I'm actually going to aim for about 32 degrees Celsius, and then I'm going to add my yeast. I'm then going to mix it again properly so that I know all of my yeast is suspended in the liquid, and also to add just a little bit more oxygen. After that, I'm going to close them up, or actually just add my fish tank heaters, close them up, put on my fermentation locks, fill it with water, and then just measure the sugar concentration twice a day. And after this week, so hopefully here by Friday, I'm going to make my conclusions, and then we'll do another video to see how they performed and basically what to do from here. So let me get my water. First things first. I think you guys, I just need to put this a little bit more back. Let me get some water, and then I'm going to start dissolving it. So we're probably going to fast forward this video, but it's really simple. So I'm not going to fill it completely. I'm just going to add some water so it can start dissolving. So you don't want to add all 20 liters at once. I'm going to definitely need some more. This is just a little bit of hot water. It has cooled down a bit now. So I'm probably going to need to get some more hot water after this. But let's just see how well it does. Now these paint mixers works amazing. So if you are working with large fermentation sizes, then I'll definitely recommend getting a paint mixer. And make sure it is properly connected, otherwise it's going to fall in. And luckily my buckets aren't that deep, but if it was 100-liter fermentation, you probably would have had to leave it there or get some other method of taking it out. Okay guys, so I've just finished adding my water to my turbo yeast. As you can see, all of them are topped up to 20 liters. And the last thing I need to do now before I add my yeast is to measure the temperature. We want to make sure that we stay within the temperature range that the yeast can actually tolerate. So let's quickly see. So if it's between 30 and 35 degrees, then I'm super happy. This one is about 31 degrees. This one is 32. 34 degrees. So all three of them are below 35 and they are above 30 degrees Celsius. So adding turbo yeast is literally the most easiest thing to do. You don't require any rehydration. You don't need to require any additional packets of nutrients or buffer that you need to add and weigh out. It's literally as easy as taking the packet, cutting it open and adding it. So I'm just going to cut this open and just sprinkle it on top. And then I'm just going to take my paint mixer and stir it in. Make sure you get rid of all of these clumps that might form while you've been pouring it in. So it needs to be completely, basically dissolved. Aeration is good. This is going to help build up that nice sterols in the cell wall. There we go. Okay, it's completely dissolved. So this is literally how easy it is to work with turbo yeast. Like I said, no rehydration, no pH adjustments. Everything is done by the turbo yeast itself. So now let's just do the second two buckets. I don't have my fish tank heaters with me right now. I'm going to have to move these fermentations to where there is electricity nearby so that I can plug them in. So I'm just going to show you how to fill the fermentation lock and everything and how to close them up properly. And then after we're done with the video, I'm just going to add the heating. So remember, everything else is constant. We are adding the exact same amount of turbo yeast. We're adding the same yeast. We're not adding two different types of turbo yeasts, so that everything else can be constant. We're working with the exact same volume. It's literally just the sugar that is different. So I'm going to go ahead and mix all of these two buckets, make sure everything's properly dissolved. So we're just going to be fast forwarding the video. Okay, so now everything is added, everything is properly dissolved. The only thing left now is to add my lids and add the fermentation locks, add the water. So let's go ahead and do that quickly. So we want to make sure that it is completely sealed off to any wine flies, to any muggies, anything that can come in, but the CO2 can still escape. Now we are going to be opening these buckets twice a day because I am going to be taking the sugar concentration twice a day. So it is going to be exposed to a little bit more oxygen, which is fine. You don't have to worry about that. So put in your fermentation locks. Remove the red caps. And then add clean water. Now there is people out there that add sodium metabisulfite solution into the fermentation locks. I don't like doing that. Reason being is if you're going to be opening the lids, there is a very big chance that some of your water is going to drain into your fermentation. Now if you add sodium metabisulfite to a fermentation, it's going to kill off all the yeast. And that is what we don't want. So I prefer just adding clean water to my fermentation locks to prevent anything like that from happening. There we go. Once you've added the water, you can just add your red caps back on. If you have lost yours, don't worry about it. The water does seal it off still. I always lose mine. So if you don't have these red locks, you don't have to worry about it. It's fine just like this as is. And then voila, everything is done, everything is prepared. The only thing left for me to do is add my fish tank heaters. But two things I just want to bring up is, firstly, I don't have any repeats. I'm just going to do these 3 20-liter fermentations. If you've watched my video on how to perform scientific experiments, you'll notice that in a proper experiment, there's always 3 repeats, because there is small changes that can happen which will influence the results. So if you have 3 of them and all 3 of them give the exact same results, then you know, okay, this experiment is believable. But this is expensive to do a whole lot of 20-liter fermentations, you know, the sugar, the yeast, etc. And the reason why I didn't do this in 1 liters, which I normally do with an experiment, which makes it much cheaper to perform, is that we are working with Turbo Yeast, which I said is a mixture of yeast, nutrients, and buffering agent. So in this packet, if I were to take out 4.5 grams of yeast, one batch of 4.5 grams would probably have more yeast than nutrients. The other one would have had more nutrients than buffer. The other one would have had a lot of buffer and yeast but no nutrients. You know, so the concentrations of each 4.5 grams I measure out individually from this packet is going to be slightly different, and that is going to influence my results. And like I said, we have to have everything else constant, so I don't want to start changing the ratios of my yeast and stuff that I'm adding. So that is why I'm doing 20-liter fermentations. So this is an exception. So what I'm going to do now, I'm going to report back in about 5 days' time and let you guys know how these fermentations went. It's been about just over a week since we started our fermentations on our proper Turbo Yeast, and today we're going to be discussing our results. So this whole experiment was on testing our new proper Turbo Yeast to see what sugar concentrations it can ferment at its optimal or at its best. So let's quickly have a look at our results. So just to go over the aims again, the first aim, our aim of our first experiment, was to see whether or not proper Turbo Yeast can complete with fermentation within a period of 72 hours with an expected alcohol concentration of 14% ABV at a fermentation temperature of between 28 or 30 and 32 degrees Celsius. So that was the aim of our first experiment. Now the aim of our second experiment was to see whether or not proper Turbo Yeast can ferment 8 kg of sugar in a 20-liter wash, similar to a fermentation with the recommended dosage rate of 6.4 kgs of sugar in a 20-liter wash. So we just basically wanted to see, if you add more sugar, will your fermentation complete? How long will it take to complete? And can we up our dosage rate to 8 kgs of sugar instead of 6.4 kgs of sugar? So when you are conducting scientific experiments, it's very important to collect the data from your experiment and then put it in some form of a graph or a table or some way that you can visually see the results. And from that result, you're going to make conclusions. So then we can have enough information to say, yes, 8 kgs of sugar does work in a fermentation with our proper Turbo Yeast, or no, it does not work, you shouldn't do that. So let's quickly see my results. So these are my 3 tables, each of them representing the different amount of sugars. So firstly, this one was 4.7 kgs of sugar I've added. This was the 14% ABV I was aiming for. Then this one was 8 kgs of sugar, so I just basically wanted to see how does it ferment when I add more than the recommended dosage rate. And that one that says 19% ABV, that is calculated according to the calculation formula, and I had to add 6.4 kgs of sugar to that experiment. So these are just all of my results. You can either use bricks as an indication of the amount of sugar in your fermentation, or your alcohol potential, or your SG. Me personally, I prefer working in bricks or alcohol potential, but if you like working in SG, you can use that as a unit as well. There's no right or wrong, as long as you've got some measurement of your sugar concentration. Some other stuff that I've also measured was my pH and my temperature. Remember, in my one of my aims, I've actually specified my fermentation temperature to see it has to be in a range of between 30 and 32 degrees Celsius. Unfortunately, it was quite cold, and some of my fermentation temperature did not actually fall in that range. You can see it was 28 was my lowest, so it's 2 degrees lower than what it should have been. I did add fish tank heaters to my fermentation, but it was a really cold week, so unfortunately that was just not enough to keep it at 30 to 32 degrees Celsius. So I've just done, every time I've measured my sugar concentrations, I've just set up it into Excel, and from these tables I drew up a fermentation curve. So we have taken the results, the Brix values of all three of my fermentations to actually compare them to one another and see them visually. So just knocking out all of those numerical values, so I can just look at the line graphs. So let's quickly look at this line graph. So you can see there's three colors, red, blue, and gray. It is very important that you know which line represents which experiment. So the red line is my 8 kgs of sugar, the fermentation where I added 8 kgs of sugar into my 20 liter wash. This one, the blue line, is where I've added 6.4 kgs of sugar, and then my grey line is where I've added 4.76 kgs of sugar. So as you can see, the shapes of the curves looks very similar, but the height where they started stabilizing is different. So let's just look at our axes that we know what we're dealing with. On the y-axis, so this one over here, this is our Brix value. So it's the measurement of the amount of sugar present in my fermentation. And then here on the x-axis, this is a representation of the hours after inoculation. So how long did it actually take my fermentation to complete? So let's start at the top one. You can see here, it's not as sharp of a decrease as there. This is just the start of fermentation. You call it the lag phase. This is the phase where your yeast starts getting used to its external environment. It starts taking up sugar, but it's not really actively fermenting yet. It's only starting its active fermentation over here. And then you can see it started stabilizing over there at just above 15 Brix, or just below 15 Brix. So what happened there is the fermentation went stuck halfway basically through fermentation, and that's not a good thing. That means there's still a lot of sugar left that could have been fermented into alcohol, but it didn't. So what could have happened there? Firstly, it cannot be because of the sugar concentration at the start of fermentation, because if there was too much sugar for the yeast to handle, it wouldn't have actually started fermenting at all. It would have killed itself immediately. It cannot be due to the ethanol concentration, because you can see the amount of sugar it actually fermented is not enough to actually go over 19% alcohol potential. So it's still very low in its alcohol concentration. So it cannot be due to alcohol. So the only two conclusions that I could have come up with that might be the reason why it stopped early is because nutrients. Proper turbo yeast consists out of a specific blend of nutrients, yeast, and its buffering agent. And the amount of nutrients in there is supposed to carry the yeast through fermentation while fermenting 6.4 kgs of sugar. It's not supposed to be fermenting more than that. So what might have happened here, it just ran out of sugar because it ran out of nutrients because there's a lot more sugar than there should have been in. So that's my one reason. Second reason is yeast is constantly dying and reproducing during fermentation. So if you've ever made a fermentation and you add about a tablespoon of yeast, you'll always notice that there's quite a thick layer of white, gooey, sticky stuff at the bottom of your fermenter when done fermenting. And that's all the yeast cells that has reproduced. So you're left with millions and millions of dead yeast cells after fermentation. Now, in order to build a healthy colony, in order to reproduce effectively, you need oxygen, you need a nice environment for the yeast, not a very stressful environment for the yeast to actually grow in. And because we are working with high concentrations of sugar, working with alcohol, we ran out of nutrients. I honestly think that there was just not a big enough yeast colony to carry through the fermentation. So maybe if we added more oxygen and we've added more nutrients, there would have been more live yeast cells that could have completed fermentation. But for me to make an accurate conclusion on that, I need to do another experiment. So let's look at our 6.4 kgs of sugar. which is the blue line. Again, it shows us there's no real activity there. The yeast is adapting to the environment, and then it has a really sharp decrease in the sugar concentration. And this curve only started stabilizing here just above 0. I think it was about 1 Brix, which means it's not completely dry, but it has fermented further than the 8 kgs of sugar. I think 1 Brix is more or less about 0.5% alcohol, which is not a lot. So we can basically say it fermented dry. So adding 6.4 kgs of sugar will give you a dry fermentation. Almost all of the sugars was consumed, and you can expect it to be done within, let's quickly see, 129 hours, which is a little bit long. I have done the same sugar wash about 2 times before this, and it actually ended up within 5 days after inoculation. But this could have been due to my one sharp temperature drop. I'll show you the results now. There we go. It was at 81 hours. Okay, you just cannot see on the screen, but it dropped to 24 degrees Celsius, which is much lower than it should have been. Reason being is my fish tank heater accidentally got switched off, so we've only realized a couple of hours afterwards. So that sharp temperature drop could have caused the yeast just not being able to really start fermenting actively again. So that can be one of the reasons. But yeah, that's basically it. So if you are using 6.4 kgs of sugar, you can expect a dry fermentation within 120 hours of inoculation. Now our last one, the grey line, I've added 4.76 kgs of sugar, which is not a lot. I mean, it's a couple of kgs less than what I should add. But as you can see here, it finished at 48 hours and it fermented completely dry. So within 2 days, you can expect a completely dry fermentation with 4.7 kgs of sugar, which is roughly about 14% if you do your calculation, that calculation formula. So if you are in a rush, you really want to get a distillation going and you do not have a lot of time, then what I will suggest is add less sugar than what is recommended to get that really, really fast fermentation rate. If you take the starting Brix and the ending Brix of these two, you'll get about a 3% alcohol concentration difference, which is not that much. I think it's fair to say that I'll rather sacrifice that 3% alcohol if I need to get a fermentation or distillation done within like 3 to 4 days. So guys, that is basically our result of our proper turbo yeast. I hope this video helped you to make good decisions regarding the usage of our distiller's yeast, our turbo yeast. So do not add 8 kgs of sugar, or rather add anything below 6.4 kgs of sugar, and that will definitely give you a complete and fast fermentation.